Topic 2.2, developing rules to multiply integers. These properties of whole numbers are also properties of integers. The zero property, which is demonstrated by multiplying any number by zero. The product will always be zero. So let's take an integer such as -3 and multiply it by 0. Your product would be 0. The multiplicative identity, which is demonstrated by multiplying any number by 1, the 1 actually does not change the identity of the number you are multiplying. So take any integer, let's say +6. Well, +6 times 1 would still be +6. The commutative property, which is demonstrated by this problem here, where you see 3 times 4 is equal to 12, and 4 times 3 is equal to 12. The 3 and the 4 just swap positions here in the second version of the problem, and that is known as the commutative property. Those numbers can commute from side to side. It doesn't matter which side they're on, the product will be the same. So take a problem like -2 times +3. The answer will be the same as +3 times -2. Doesn't matter which order they're in. And the distributive property. The distributive property is demonstrated by this problem here, where we have 3 times 3 plus 5. We can distribute the value of 3 over the two values in brackets here. And this looks like this. So 3 times 3 plus 3 times 5 is the same as taking 3 and multiplying that by the sum of 3 and 5. Let's have a look at some examples. -3 times 0 will equal 0 because any number times 0 equals 0. +9 times +1 will equal +9 because any number multiplied by 1 will retain its value. 0 times -3 will be 0 because, again, any number times 0 is 0. And +1 times +9 will equal +9. The +9 retains its value. Multiplying it by 1 does not change it. Okay, now the right-hand column over here, and the left-hand column, they just show that the commutative property is also true when you're working with integers. So it doesn't matter whether the -3 comes first or second, your product is going to be the same. There are two ways to solve a problem like this. The first is to take the +3 and to multiply it by the sum of the two values in the brackets. That would look like this. +3 times the sum of +2 and +5, which is +7. And this would equal +21. The other way to solve this problem is to use the distributive property. And that simply means to take the +3 and to multiply it by each of these two values separately, and then to add those two products up in the end. And that looks like this. So we take the +3, we multiply it by +2. And we keep this separate from +3 times +5. And then we would add up those two products. So this would equal +6 plus +15, which would be +21. So either of the two methods works to solve that problem. There are two rules to keep in mind when multiplying integers. When the integers have opposite signs, the product is negative. And when the integers have the same signs, the product is positive. That's it. Two rules. So if we're going to multiply a positive by a negative integer, our answer is going to be negative. If we're going to multiply a negative by a positive integer, our answer will be negative. And if the signs are the same, so if they are both positive or if they are both negative, the answer is going to be positive. Now let's try using those rules to answer these questions. Positive 8 times positive 2. These signs are the same, so our answer is going to be positive. So 8 times 2 is 16, and that's going to be a positive 16. Negative 5 times negative 4. These signs are the same, they're both negative, so our answer is going to be positive. So 5 times 4 is equal to 20, and this is going to be a positive 20.